So we're looking at section 5.7 today, and this is where we're solving polynomial equations. This is one of the applications of factoring. Like, why do we want to do this? And well, we get these polynomials, and they'll show up in different science applications. They'll show up in engineering applications. And one of the things we want to learn how to do is solve for x. We solved for x before using some certain techniques where we try to isolate x on one side of an equation, something with an equal sign. And we use cancellations, doing the opposite of what an operator does. For example, let's say we have this. Let's say something like this. And then what we would do, add 2 to both sides. And so we find out that x is equal to 3. Now, this is what we would do when we have what we call a linear equation. In other words, x doesn't have an exponent on it. Well, yet technically does. It has the exponent of 1. But that's it. Polynomials are nonlinear. So we're looking at things like this. We want to solve for x for this kind of equation. So how do we do that? Well, in this case, the old tricks won't necessarily work. So what we're going to do is we're going to use a very special kind of tool that lets us solve for x. And it's called the zero product property. Now, the way the zero product property works is this. Let's say we have 2 things, let's say A and B. So let's multiply them together, take a product of them. So this is A times B. And let's suppose this product is equal to 0. Now, this is only going to be equal to 0 if there's one of 3 possibilities. Really 2, but if A is 0, or if B is 0. Because anything times 0 is 0. And of course, you could have both A and B equal to 0. So this is true whenever A is 0 or B is 0. So what do we do with this? Well, what we're going to do, we're going to take our polynomials and we're going to set them equal to 0. We'll do sometimes a little algebra to do that. And then we're going to try to factor them as products. So you have a product of like a binomial times a binomial. And then once you've got this polynomial turned into products, like this. Well, this could be a binomial. This could be another binomial. We'll set each of these binomials equal to 0 and find out, well, which value of x would cause this binomial to be 0 and which value of x would cause that binomial to be 0. And then that will give us the values of x that solve the equation. And what's special about these kinds of equations is we're not going to just get one value of x that can solve it. It'll turn out you can get 2, 3 values of x that could solve it, maybe more. So let's see how this works. Let's go back to this. Now, what we want to do, we want to solve for x. So here's the trick. We're going to factor this into products. So this is how we're going to implement this trick. We're going to factor this polynomial into product of binomials. So again, the way we factor this, since there's an invisible 1 here and nothing else, we're going to do guess and check. So we want two numbers that add up to 5 and that multiply to 6. Now, what two numbers do this? Well, 2 works and 3 works. Good to go. And we're good to go again. These work. So that means A is going to be 2 and B is going to be 3. So this will be x plus A, or x plus 2, and then x plus B, or x plus 3. So we factor this. Now, what's different about this situation is we have it equals to 0. Well, we have a product of two things that equal 0. This equation is only going to be true according to the zero product property. That means when you pick a value for x, it better make this 0, because 0 times anything will be 0, or it's going to make this 0 our choice for x. This times 0 will be 0. So we need to consider two possibilities. This will be our A. And this will be our B. Our A and our B. So let's consider the possibility that A is equal to 0. So that means x plus 2 would be 0. And what choice of x does that? Well, solve for x. So it's x is minus 2. Now what that says, if we take x is minus 2 and we put it back into this equation. Now, negative 2 plus 3 is going to be positive 1. So this turns out to be positive 1 in that case. So it doesn't do anything. But negative 2 plus 2 is 0. So we'll get 0 times 1. That is still equal to 0. It works. Now, let's consider the other case, B. This means x plus 3 is equal to 0. Or subtract 3. X is negative 3. Now again, if we take negative 3 and we put it here, negative 3 plus 2 is negative 1. But negative 3 plus 3 will be 0. So if we let x be negative 3, what we're going to get is negative 1 times 0 still is equal to 0. So these values of x work. Now, what the book's going to want you to do, what the homework assignments are going to want you to do, is enter these answers as a set. So our solution will be the set containing negative 3 and negative 2. And that's going to be your answer. All right. Now let's take a look. Let's do another one. Let's say we got this. So now we've got a number on that x squared, not that invisible 1. So we're going to have to use the AC method. So this is A, B, and then including the sign. I want to include negative signs. That's going to be C. So first off, A times C will be 3 times negative 8. We get negative 24. Now, we need 2 numbers, n1 times n2, that equals negative 24, and the sum of these numbers will be positive 10. What would do it? Well, how about this? Let's say we take 12 times negative 2. Well, that'll be negative 24. Okay, so far so good. And then let's try 12 plus negative 2. Well, that'll be positive 10. So this tells us that n1 is 12. n2 will be negative 2. So now that we have that, so we rewrite 10x is 12x minus 2x minus 8 is equal to 0. And again, you can check 12x, subtract 2x is 10x, or 12x plus negative 2x is 10x. So now we're going to do grouping. So first group, think about this. Looking at variables, what can we extract from each of these? It's got to be the same thing from both of these. Well, we can extract an x from here, and we can extract an x from here. So there's an x in common to those two terms. We could also take a look at this. This is 3. This is 3 times 2 times 2. So what do we have in common here? We've got a 3 and 3. So we could extract a 3x. Now let's take a look at this. Make a little room here. So as far as variables go, for the second group of 2, there's nothing in common. This has an x, this doesn't have anything. So nothing with variables. Now what about numbers? Now again, I recommend sort of breaking out that negative sign. So instead of negative 2, I'm going to go negative 1 times 2. Instead of negative 8, negative 1 times 2 times 2 times 2. I'm letting negative 1 represent the negative sign. So what do we have in common here? Well, both of these have a negative 1, and both of them have at least 1, 2. So negative 1 times 2 is negative 2. So we're going to extract a negative 2. So now let's rewrite this. I'm going to do plus negative 2 times x plus -2 times, I gotta squeeze it in here, times 4. That's going to be equal to 0. Kind of hard to see. And so what I've done, I've extracted the minus sign, because the minus sign's on both of these terms. When you extract a minus sign, you're going to get a plus. So our minus sign is here, minus sign is here. We're extracting it. So let's pull out this 3x here. X plus 4 equals 0. We extract the x plus 4 because it's common to both of those terms, or common to both groups. I rewrite this as just subtract 2. Now, in the past, we would be done. We've factored this and we're finished. But we still need to solve for 0. So we're going to take this one step further. So we can let this be A, this be B. So first off, we'll consider A is equal to 0. I'm going to kind of skip a little of the notation here just so it's more efficient. So first off, let's set this equal to 0. And then we solve for x. And then we set this equal to 0. Add 2 to both sides. Divide by 3. And I've got a number divided by a number here. They're not going to go in evenly. So I'm going to write it as a fraction. 2 fraction bar 3. So these are the two answers we're going to get. To make that first binomial equal to 0, let x be -4. To make the first binomial 0, who cares about the second binomial? It can be whatever it wants. 0 times that number will make everything 0. And then same thing for the second binomial. It'll become 0 when x is 2/3. And then when it becomes 0, who cares what number the first binomial becomes? Any number times 0 will be 0. So finally, we put our answers in set notation. And that's going to be our answer. Now let's take a look at another one. Let's see here. There we go. Now let's take a look at this. You could try to divide both sides by 9 and take the square root of both sides. We haven't really talked about square roots yet, though, so we better hold back. we're going to do something different. When we're dealing with these polynomials, we want one side with terms, the other side with 0. So what we'll do is subtract 100 from both sides. Now, why do we do this? Well, again, we want to use the zero product property. It only works if there's a 0 here on this other side. It won't work if this is something other than 0. Can't use a zero product property. No way. Now let's take a look at this. Now, if we take a look here, this looks like 3x squared. If you distribute your 2, you'll get 9. Distribute the 2, you'll get x squared. Remember, you're distributing it as an exponent, not 2 times 3. But you distribute it as an exponent of 3 and an exponent of x. And in this one, same thing. 100 is 10 squared. So this is really something squared. This is really something squared. And we're taking the difference of these two things. So we actually have a phrase for this. It's called difference of squares. And the pattern works like this. Now, you might have seen it written like this. But either way, it's the same thing. You can write it like this, or you can write it like that. It's perfectly fine. So now that we have that, let's follow our pattern. So we can say A is 3x, and B is going to be 10. So we'll get 3x minus 10, or A minus B, times A plus B. There's A plus, there's B, and it's still equal to 0. So now we've got to solve A equals 0 and B equals 0. Because we have an A, okay, I'm sorry, not the A and B here. In fact, let me make this a little easier. Let's call this, give it some Greek letters. Have a little fun. Alpha and beta. So alpha minus beta, alpha plus beta. It's going to be the same type of pattern. But if this is 0, then 0 times this makes everything 0. If this is 0, then whatever this is, what number times 0 will give you 0. So let's watch how this goes. So we got to ask this question. What value of x makes this equal to 0? So add 10 to both sides. (10) fraction bar 3. Again, using that fact that division is just another way of writing a fraction, or a fraction is another way of writing division. So now we have to deal with this one. I'm going to subtract 10 from both sides. So these are going to be our two answers. And so for the grand answer, we're going to have that. Again, the set of these two right here. So let's try another one like this. We have to move things around. Let's see here. Let's do this one. Now, once again, we want to solve these using the zero product property. Now, we can't do that unless one of the sides is 0. So this is already positive. We could keep it positive, or we could subtract it to the other side. We could do it either way. Oftentimes, you'll see people keep this one positive and subtract the other two for whatever reasons. So just out of habit, I'm going to do the same thing. But you don't have to. You can subtract this. And let's live dangerously. Let's be different. So let's subtract 9x squared from both sides. And if we do that, we'll get 0. This will be negative 9x squared plus 30x minus 25. Now again, we have a number in front of the x squared that's not the invisible 1. So we've got to use the AC method. So we have our A, including the sign, B, and then C, including the sign. So A times C. Let's see here, what's that going to be? 225? So that's our A times C. Now, we need two numbers that multiply to 225. And they're going to add up to positive 30. They add up to 225. But add up, they multiply to 225, but add up to positive 30. Now, what could that be? And let me just double check my math. I didn't make an arithmetic mistake. Okay, I think we should be good. Okay. All right. Let's make sure, okay. So what could we do? Two numbers that multiply to 225 and add up to 30. Well, let's try something. Let me grab my calculator. Let's play with some numbers. So 225 is it ends in the number 5. So that means what we can do is always divide it by 5. So what that tells us is 45. So sure enough, 225, but clearly this isn't going to work if we add. So that works, but this is going to add up to 50. It's not going to go. Now, I can tell you a little trick here. If you take the digits of 225, and this is sort of a slick math trick, if you add up the digits, if you get a number that's divisible by 3, then this number will be divisible by 3. So 2 plus 2 is 4. 4 plus 5 is 9. 9 is divisible by 3. So here's the trick. Therefore, this number is divisible by 3. Now, I don't know if this is going to help us too much. Let's see what it does. It's not going to work initially. 225 divided by 3 is 75. But 75 is also divisible by 3. And 25. So that means 6 times 25, well, that gives you 150. That's not going to go. Let's see here. 9 times 25. It's not going to work. It's going to be a little big. $34. That's not going to go. But are we getting closer? Let's see here. Let's play around with this. I'm going to try. I don't think 10 won't do it. 11, probably not. Let's try 15. Ooh. 225 divided by 15 is 15. So check this out. That means 15 times 15 is 225. So far, so good. And check this out. Oh my gosh, this is amazing. 30 works. So it turns out in this case, N1 and N2 are the same number. N1 is 15. N2 will also be 15. So now, using this equation here, because we moved the 9 to a minus 9 squared, so 9 squared was moved over to become minus 9 squared. We'll rewrite this middle term. As the sum of 2 15s. Now here you can see an argument why you try to make things maybe as positive as you can. Because if we move these two terms over, you have 9x squared, a minus 30, and a plus 25. So it's just fewer minus ones we have to deal with, but it's not the end of the world. So let's approach this by grouping. First group. Let's look at the variable. X squared and an x, we can at least get an x from both terms. So far, so good. Now this is 3 times 5. This is minus 1 times 3 times 3. Now, there's a very slick trick here you can do. And what you can do, we'll hold off on that. We won't get too slick. We'll just go with it like this. So we've got a 3, 3. We can extract a 3x. Now, we are going to need to be slick on this other side. So let's take a look at variables. Well, nothing here, x, nothing in common. So this is 3 times 5. And we can call this minus 1 times 5 times 5. So what do we have in common? Well, we've got a 5. And we've got another 5. So we can extract 5s from here and 3x from here. Now, if we do that, move back to blue. So we can pull out the 3x, we can pull out the 5s. And there we go. Oh, I'm missing a 3. You can leave a 3 there, forgot. Pardon me. Where that 3 disappeared, there's only one 3 that was in common. The -1 and the 3 is going to stay behind. -1 times 3, -3, -3. Now, it's very tempting to say, well, factor out what's in common between the two groups. But here's the thing. This is -3x plus 5. This is 3x plus -5. Or if we want to rewrite it, we can do this. So what do we do here? Well, we can still do some factor. What we can say is we can call this -1 times 3. And what we can call this -1 times -1, which is just +1 times 5. So something positive can be written as -1 times -1. What this does is now we have something in common between these two numbers. So in other words, you can think of it like this. Maybe I'm going a little bit too fast here. -1 times 3. We could call this 1 times 5, which is kind of lame because 1 times 5 is just 5. But then we can break it down to -1 times -1 times 5. Now we have something in common. A -1 and a -1. So -1 times 5 is -5. So we'll leave this behind, the -5. We have what's left over here. So we can pull out that -1. And if we do that, we'll have -1 times 3x. And then we have 3x plus -5 plus 5 times 3x minus 5. And now remember that adding a negative is just subtraction. -1 times 3 is -3. So you get minus 3x times 3x minus 5 plus 5, 3x minus 5. So now we finally got the same binomial in the two groups. So the trick to this, when we're off by a minus, and you don't have to go through all these steps, what you can do is when you have the same terms, but they differ by sign, where it's negative, positive, and then positive, negative, you can just go from here down to here. Just factor out a -1. Factoring out a -1 will make this positive. Factoring out a -1, it's kind of a funny thing to say, but it'll make this negative. It'll switch the signs. So what you can do is you can go from here down to there. And this is a shortcut. This is just sort of a math trick you can kind of memorize. But if this is negative and positive, and you want it to be positive and negative, well then factor out a -1, which will make this go from positive to negative. And once you factor out that -1, switch the signs, and you're good to go. So now we've got this, we've got 3x minus 5, 3x minus 5 in the same groups. Factor out or extract that 3x minus 5. So now this is our capital A, this is our capital B. So what causes this to be 0? Let's find out. And that's going to be one of our answers, 5/3. Let's take a look at this. Subtract 5. Divide by -3. Now, negative divided by a negative is going to be positive. So once again, we're going to get 5/3. So we get 5/3 twice. So what does that mean? Well, in this case, if you put x as 5/3, both of these binomials become 0. So that means for this problem, we only get one answer. well, it's x is 5/3, or as a set, it's a set containing one improper fraction, 5/3. So let me talk about that little trick that we did. I just want to go over that one more time. So if you have something like this, the way you can switch the signs on these, factor a -1. This is a little math trick. So this will become positive, and that will become negative. In fact, when you factor a -1, it switches the signs on everything. So let's say we have this. If you factor -1, this positive will now become negative. This negative will become positive. This negative will become positive. And this positive will become negative. So you can factor out a -1 to switch the signs on everything. And the way you can check this, if you distribute this -1 back to the x and back to the -3, negative times positive would be negative. Negative times negative would be positive. Same thing here. Negative times negative would be positive. Negative times positive would be negative. Negative times positive would be negative. Negative times negative would be positive. So if you need to switch the signs on things, just factor out a negative. Let's see here. So let me do at least a couple more. Let's say you have this. So with all of these, the recommended approach is you want to get rid of these denominators. So you want to find a number that the 4 and the 2 both divide into. Now, what number does 4 divide into and also 2 divide into? Well, and this means with no remainders left over. Well, it's the number 4. No remainder. And again, no remainder. So we'll just let n equal 4. So what we're going to do, we're going to take this n and multiply it on both sides of this equation, which means we're going to multiply after distributing everything in that equation. Now on this other side, it's pretty simple, 4 times 0. So we'll distribute this 4. Then 4 times 0 is equal to 0. So now we're going to do our divisions. This 4 is going to divide into this and this. It's going to divide into the entire product. So we can be kind of picky. We can send it into the x squared, or we can send it into the 4. We're going to send it into the 4. That's what we wanted to do in the first place. So 4 goes in the 4. one time. 2 goes in the 4 2 times. So we're going to get 1 times x squared. And this will be 2 times 5x. This will be 4 times 6, which is 24. Or what we're going to get that. So now what we're going to do, we've gotten rid of denominators. That just makes life so much easier. So now that we've gotten rid of those, let's factor this so we can use our zero product property. So we want 2 numbers that add up to -10 and multiply to 24. Again, there's the invisible 1 there, so we're not going to use the AC method. We're using guess and check. So A plus B is -10. A times B is +24. You can think about this, experiment, but what you're going to ultimately come up with. Let A be -4, B be -6. There's a clue that they both have to be negative. Positive times positive is positive. Negative times negative is positive. So that means you got to have 2 positive numbers or 2 negative numbers. Well, 2 positive numbers will not add up to a negative. So only 2 negatives will do that. Well, unless you have a positive and negative, sometimes that will add up to a negative. But we can't have positive and negative. They gotta both be negative or both be positive. So negative and negative will add up to a negative. Negative and negative will multiply to a positive. So there we go. We can test it out. Sure enough, we get -10. And we get +24. We're good to go. So we'll get x plus -4, x plus -6, 0, or x minus 4, x minus 6 is 0. So again, we're going to solve for x. If this is 0, the whole thing becomes 0. If this turns out to be 0, the whole thing comes out to be 0. So what values of x would make this 0 and would also, well, not necessarily also, what value of x would make this 0, and then what value of x would make that 0? So let's take a look. Again, add 4 to both sides. Where x is 4. And for this one, so our answers are 4 and 6, or 4, 6 as a set. So let's take, okay, we'll do one more here. Let's see. We'll need to talk about the Pythagorean theorem. It's one of the application problems. I just want to mention it. So let's say we have this. There's this and one other one I want to do. It's a tricky one here. You want to be careful of. Let's see. They mention it in the text material, but they don't mention it in one of the problems. At least not the. Oh, yeah, I do see one. Okay. We got at least a couple more. Now this is 4 terms. This is a 4-term polynomial. So we're just going to go to grouping. So we got this right here, first group. Variables, we have an x squared. We could get an x squared. We have an x squared. As for numbers, this is a 1. This is a -1 times 2. Not really going to do us any good. So really nothing in common with numbers. Okay. Now let's take a look at this other side though. Well, nothing in terms of variables, and as far as numbers go, nothing there either. So no extraction for that group yet. So let's rewrite this. We'll pull out an x squared. Oops, getting a little ahead of myself. So far, that's all we've got. Pull out this x squared. So here we are again, that same situation. Let me not forget this is equal to 0. We have an x and a 2, x and a 2, but they differ by sign. Positive, negative, negative, positive. So again, what we can do is from here, extract a -1. X squared, x minus 2. So if we extract a -1 from here and from here, now we extract a -1, that'll become plus. We'll have our -1. And then we change the signs. We extracted the -1 here, so that's plus. We're going to get something like this. So now we have x minus 2 and x minus 2. We can extract the x minus 2. When you're not sure what sign should go here, you can usually do just fine putting a plus sign. So if we do the extraction here, what this will become is that it becomes -1 times x minus 2. And since if you're not sure, like the sign got swallowed up in here, you can put a plus sign and you're going to be okay, at least in this instance. There are some tricks with mathematics, and not necessarily things with factoring, but there are other tricks with mathematics where you got to be careful. But in this case, you're going to be all right with what we're doing with this factoring. So we've got this. We think we're done. We're not done. Check this out. This is a difference of squares. X squared will give you x squared. 1 squared will give you 1. So what we can do, we can write this using the pattern. Where for us, A will be x, and B is going to be 1. A squared minus B squared. And so we'll do a minus b, a plus b, and it's still equal to 0. Now, in this case, the zero product property has a product of 3 things, say a first binomial, second binomial, third binomial. If this is 0, it zeroes out everything else. If this is 0, it'll zero out everything else. And if this was 0, it would zero out everything else. Like if you had 3 times 2 times 0, you're still going to get 0. So for this, we get x is 2. So I'm writing it off to the side here because we're running out of space. And then finally for this one, so we get 3 answers for this one. So that means if we write these as a set, negative 1, 1, and 2. And that's going to be your answer. Now let me show you a sort of peculiar one that it's easy to make this mistake. Now, the temptation for most students for this type of problem is to divide both sides by x. So you would seemingly cancel an x, you get 2x equals 5. Don't do that. And the reason is this, excuse me, we haven't been told what x has been defined for. And it's usually defined for all possible numbers. So unless they tell us a restriction on x, like don't let x be negative 1, well, x could be negative 1. So in this case, what could be going on is what if x is 0? Well, if x is 0, dividing by x is dividing by 0. Can't do that. So we don't want to try to divide by x. Now, if somebody came along and said, x cannot be 0, well, then we could divide by x. We'd be fine. But we don't have anything coming around saying that. So we have to assume x could be 0. So what we do is this. We'll subtract 5x from both sides. And now we're going to factor out a greatest common factor. And we can get an x here, or we can get an x here. So if we factor out that x, we're going to get this. Well, here's that 2x minus 5, but this extra x is key. Again, we're going to use the zero product principle. This x times this equals 0. So this right here would be like in the zero product principle, the capital A and capital B, we're multiplying A times B. So we set A equal to 0. Well, that means we set x equal to 0, and we're done. Because sure enough, if x was 0, well, this would become negative 5, because 2 times 0 is 0. 0 minus 5 is negative 5. But who cares? 0 times negative 5 will be 0. Now for B, add 5 to both sides. Divide by 2. We have x is 5/2. So what this means is this. Our answer is 0 and 5/2. So you want to avoid problems where you're dividing by x. Don't divide by x. Because unless they tell you x will never be 0. So just a little trick question there. So the last thing I want to mention has to do with the application problems. And it's something called the Pythagorean theorem. What it says is this. If you have a triangle that has a base or a bottom that's perfectly level and flat, and the back of this triangle is perfectly up and down, so it forms what's called a 90-degree angle. This little symbol symbolizes 90-degree angle. Think of a very uncomfortable chair where it's perfectly flat, perfectly up and down, and they meet at a perfect corner. This is only true for triangles that have this perfect corner. For triangles that don't have any perfect corners in them, we got to use some different formulas. But if you have one of these perfect 90-degree corners, and this is a length of A, a length of B, and this is a length of C, then these sides have a special relationship. A squared plus B squared will equal C squared. So this is always going to be true. Again, you have to have a triangle with that perfect corner in it. So, to give you an example, show how this works. If this is 4, 3, then this is going to be 5. How come? Well, let's say this is going to be A, B, C. So according to the Pythagorean theorem, and keep in mind, C is always the side directly across from that perfect 90-degree angle, that perfect corner. It's always the side directly across. So it'd always be this squared plus this squared equals this sort of this inclined side squared. And to show you that this is true, let's take a look at A squared plus B squared equals C squared. Well, that means that 4 squared plus 3 squared, well, that better equal 5 squared. This Pythagorean theorem is true. This better be what happens. Let's see. Well, 4 squared is 16. 3 squared is 9. 5 squared is 25. So you can do the math on a piece of paper. Maybe you can do it in your head or bust out a calculator. 16 plus 9, sure enough, it's 25. So the theorem works. There we go. So just something to throw at you out there. Now let's see. They do mention one other thing, is the thing with parabolas. Parabola is a kind of a curve that we study. Remember when we talked about functions? So functions and intercepts. So if you recall, we had y, say it equals 3x plus 1. If we set y equal to 0, we want to find what's called the x-intercept. We set y equal to 0. And we're going to get this. X is negative 1/3. So if we were to graph this, y-intercept would be here. Divide this into 3 parts. A third, a third, and a third. Negative 1/3, negative 2/3, negative 3/3, or 3 divided by 3 is 1, negative 1. So x is negative 1/3 when y is 0. So what we find is this. By setting our function equal to 0 and solving for x, we find where our function crosses the x-axis. That's what we're finding out. So if we set our function equal to 0 and solve for x, we're finding out where this function crosses the x-axis. Well, it's true with lines. It's also true with polynomials. So let me do an example. So what do we do here? Well, once again, to find out where it crosses the x-axis, we want to find the x-intercept. So for the x-intercept, again, we let y equal 0. So we got that. So what that gives us is the same situation we've been wrestling with this entire time. We now have 0 as x squared plus 5x plus 6. Now this is what we worked on this one at the beginning of the class today. This will factor out to using the guess and check method. And we find out that x is negative 2 and x is negative 3. So what is our answer? Well, for both of these x values, y is 0. y is going to be equal to 0. So that means the x-intercepts, we're going to have 2 x-intercepts. We're going to have 2 x-intercepts. So what they'll be is y is 0, x is -2, and y is 0, x is -3. And oftentimes what they'll have you do is put these 2 points in a set and separate the points also with a comma. All right. So that's pretty much it for this section. That's going to pretty much do it. If you have any questions, let me know. And other than that, yeah, just let me know. And hopefully you're back from you soon.